Hi, I'm Sarah, and today we're going to be examining the kinetics of a hydrolysis reaction using colour to follow the progress of the reaction. To do this lab, first we're going to construct a calibration curve using 5 different concentrations of dye and measuring it using the spectrophotometer. From here, we'll take what we've determined as the ideal concentration of dye to perform the hydrolysis reaction, which is the reaction of the dye with sodium hydroxide. We will also follow this using the spectrophotometer. From here, we're going to graph our results of the absorbance values versus time and use this to determine the kinetics of the reaction. The main hazard of this lab is using sodium hydroxide, so if you spill this on your skin, make sure you rinse it with copious amounts of water and then tell a demonstrator or supervisor. The dye in this lab also stains heavily, so try to avoid getting it on your skin or anything that you don't want stained. These are the spectrophotometers you'll be using in the lab. Follow the card next to the spectrophotometer to work out how to blank your spectrophotometer and how to read from your samples. Your sample will go in these cuvettes. As you can see, the cuvette has ridged sides and clear sides. The ridged sides are for you to hold, while the clear sides is where the measurement is taken. The measurement is taken using a beam of light, so don't touch the clear sides or else you'll get fingerprints on them, which will affect the way the light travels and you won't get an accurate reading. If you think your cuvette has dirty clear sides, you can clean them with a paper towel before you start your experiment. When filling your cuvette with your sample, make sure you fill it roughly 2/3 full, which is approximately up to this frosted line. Make sure you rinse your cuvette with your sample before you read it, or else there might be anything in there that could dilute or alter the sample reading and you won't get an accurate value. When putting the cuvette into the spectrophotometer, align this arrow with this arrow on the spectrophotometer and make sure the cuvette is pushed right down. Before you take your reading, make sure there are no air bubbles or fluff in the side of this cuvette, as this will also affect your reading. Follow the instructions on the card to work out how to read your sample. You'll see in your report sheet that you're going to be making up 5 different concentrations of dye in your groups. If you have a group of 5, this is quite easy, you just do 1 each. If you have a group of any fewer number than 5, some of you might have to do 2. Take your allocated volume of dye and put it into your 100 ml volumetric flask. Make sure you rinse whatever you collected the dye in, and then make up the volume to the line using distilled water. Make sure that the bottom of your meniscus is on the line. Make sure you then stopper your flask and mix the solution by gently inverting. Now you will measure the absorbances of your solutions. Start with the most dilute and work your way up to the most concentrated. Make sure that first you rinse the cuvette with water and then with the solution you're going to measure, before filling it up to just under the line and measuring the absorbance. Make sure you all fill out all of the absorbance values and concentrations in your report sheet so that you can construct your calibration curve. In lectures, you will have learnt that different reaction conditions can produce different kinetics, and here we're going to examine the kinetics of the reaction of the hydrolysis of dye, which occurs when you add sodium hydroxide. In your calibration curve, you should have determined which concentration of dye produces an absorbance that's roughly 0.8 to 1. This will produce the most accurate readings in the next reaction, so you need to make sure that this is the concentration you end up with. Make sure you read this section of your lab manual very carefully. Now that you've chosen a concentration from your calibration curve, make up a new solution that is twice as concentrated as this original solution. This is because in the next step, you're going to be adding an equal volume of sodium hydroxide, which will dilute your solution. You have to make sure that you work very quickly during this step of the reaction, as soon as you add the sodium hydroxide, the reaction will begin. So make sure that you make up your solution, blank your spectrophotometer, and rinse your cuvette, ready to go. Take the required volume of your new crystal violet solution into a measuring cylinder and the same volume of your sodium hydroxide solution into your conical flask. With your cuvette prepared and ready, add the crystal violet to the sodium hydroxide, mix quickly and then add it to your cuvette and take your first reading as soon as possible. From here, continue to take your absorbance readings at regular intervals and record them in your report sheet. For this part of the lab, you need to be really organised. Take your first time 0 reading as quickly as possible and make sure that one person is reading out the times, another can be reading the absorbances, and while the absorbance values are being read out, other group members can immediately convert them to log of absorbance values and 1 over absorbance. Once you're sure that your reaction is finished, because no more change in absorbance is observed, all members of the group must write down all of the values and construct all 3 graphs. Following the instructions in your lab manual, you will then construct the 3 graphs. From these graphs, you can determine the value of X and the rate of the reaction. X is the order of the reaction with respect to dye. Most of the marks in this lab are gained by doing your graphs correctly. A good graph should have a concise title that clearly lays out what the graph entails, logical axes that take up the most of the space given, as well as having intervals of reasonable amounts, good axis titles, and points that are clear, such as crosses or a dot with a circle around them. The line of best fit for a linear graph should be ruled and go through 0, and the line of best fit for a curved graph should be neatly sketched. As you can see, the experimental section of this lab is quite straightforward and won't take you very long. However, you must be organised so that you can get on to drawing all 3 graphs correctly. The graphing is the most important and also the most difficult part of this lab, so if you have any difficulties, ask a demonstrator for some help as soon as possible. Your supervisor will tell you how to get into your groups and find your spectrophotometers. Remember, your demonstrators are here to help you, so if you have any questions, make sure you ask us, and remember to have fun.